Hey everyone, in this lesson we're going to take a look at logic and really the basics about statements and what mathematical proof ends up being built upon. This idea that a mathematical statement has to be something that can be either true or false, but really can't be both at the same time. So the very beginning of this lesson, we really take a look at how do we take a statement like the one that you see here. If you clean your room, then you get ice cream. And recognize the parts of that statement and look how to write it and rewrite it mathematically, as well as expand to now how can I prove that this statement is true or false in a logical way. So to start out with, a lot of times you are going to see that we will take two statements. One of these statements is you clean your room. The other statement is you get ice cream. And we put those statements together in some way, shape, or form. In this way, we really have a hypothesis and conclusion, all right? And if you do this, then this is going to happen. A lot of times mathematics, and I don't know why we use these letters other than my grandmother always said to mind your P's and Q's, we will take these two statements and say this is statement P. P is you clean your room. Q is you get ice cream. Now by themselves, each of those statements could be true or false. You may or may not clean your room. So you clean your room is true if you do it, it's false if you don't. You get ice cream is true if you're eating it, false if you're not. So we will have these two statements. And we use P's and Q's because we use a lot of mathematical symbols in order to write statements like this and make them a little bit smaller. So for example, the one that you see here is written like this. If P, then Q. And you'll see this little double arrow. Or sometimes people will just write, P, then Q. Right? If P happens, then Q happens. We also use another symbol that is the negation symbol, which really means not. So if I were to simply write this statement, that means not P, or in this case, if you do not clean your room. Or I could write, if you do not clean your room, then you do not get ice cream, right? Another way to say this exact same sentence. Whether or not those two things are both the exact same meaning really can be done with a truth table that I'll get to later. Another two symbols that we are going to see is the symbol for and the symbol for or. When I'm writing sentences then, I could have P and Q. You clean your room and you get ice cream. P or Q. You clean your room or you get ice cream. Notice I did not say if in either of those two. These are just two separate statements. They could both be true, they could be both false, right? I could come home and say, yeah, yesterday I cleaned my room and I got ice cream. Those are two separate things that may or may not have happened, and someone might question me like, did you really clean your room? Let me go look. And did you really get ice cream? Let me ask your parents. Whatever it happens here, we are really looking at these three things. The idea that I can use and make a hypothesis conclusion. I can take and, or, and I should have said four things because there's the negation. So we're going to write a lot of things with just those four symbols, right? So in this statement, I can write them a lot of different ways using those, and I've already written some of them. I can also take this statement and turn it around and say this. If you get ice cream, then you clean your room. Or I could say, if you get ice cream, then you do not clean your room, right? And if, then, a hypothesis conclusion. If we add a third statement in here, how about I delete all of these things, And let's just write this as if, instead of actually even having the sentence up here, let's just write the three statements that I'm going to have. So statement number one, I'm going to call P. P is you clean your room. Q, and let's do it down here, is you get good grades. And R is going to be you get ice cream. And I think you can see where these things are going. Now I can put things together and start to get a little bit more complicated. Like I could say P, I could say P, then R. If you clean your room, then you get ice cream. If you get good grades, then you get ice cream. A more complicated one, if you clean your room and get good grades, then you get ice cream. So starting to put these things together with the idea of and or. So with that, let's start thinking about how a truth table works. Each of these statements, so P by itself, you clean your room, P can either be true or false. Q can either be true or false. R can either be true or false. So when I start putting these together in a truth table, I'm trying to look for all of the combinations of true and false for this. And here's, I'll erase this because I kind of got ahead of myself there. Here's what a truth table, and I am only going to do a truth table in this sense for this one right here. P, then R. And that truth table is going to look like this. Here's the letter P, and the letter R, the statement. Now I know that these could both be true. I know that the first one could be true and the second one could be false. The first one could be false and the second one could be true, or they're both false. Now this takes a little bit of practice, but you're going to notice all truth tables with two statements get set up the same way, right? The order doesn't matter, but they're either both true, they're both false, or one is true and the other is false. Now, when we are taking a look at truth tables, it allows us to make logical conclusions with those two letters. So for example, I might say P and R. And they means they both must be true. If they are not both true, this whole statement is false. So basically think about the observation. Like the statement is, you clean your room and you got ice cream. Or someone makes the statement, I cleaned my room and got ice cream. If you came in and observed and said, well, I looked at your room and I saw it was clean, I looked at your face and I saw that you had ice cream on it, then this was a true statement. If I look at your room and it's clean, but you didn't get ice cream, false. If I looked at your room and it was messy and your face had ice cream on it, so you got one of them, that's still a false statement. And if you didn't do either of them, false, right? So really, and is only true if both of the statements are true. Let's take a look at the or statement. Or says one must be true. Doesn't matter which one, but one of them must be true. So in this case, I can stop thinking about all of these statements and just look and say, if either one of these is true, the statement is true. If either one of P and R, or in this case P or R, is true, then the whole statement is true. The one that most people struggle with then is the idea of this conditional statement. If, then Q, or if P, then R. For a conditional statement, the only way that you can prove it false is to do this. true, then false. Meaning I did the first part, but the second part didn't come true. Like I cleaned my room, but I didn't get ice cream, right? Which is strange because that means a couple of these that are a little bit, when we think them through, we want to say like, oh, that's a false statement, but that's not how this works. It's kind of like the innocent till proven guilty. Like here is the statement. If I clean my room, then I get ice cream. If someone comes and observes and says, yeah, this person cleaned their room and they got ice cream, that's obviously a true statement. If they cleaned their room, but their parents didn't get them ice cream, false statement. Here is where people get tripped up. These two, the hypothesis, the first part of that statement is false. If the hypothesis is false, then I cannot make any claim about whether or not that statement. It's like they didn't clean their room. So because they didn't clean their room, I'm kind of stuck assuming that the statement is true. Like they didn't clean their room and they got ice cream doesn't mean it was a false statement. It just means that their parents were nice. So if in a conditional, if the hypothesis is true, or excuse me, if the hypothesis is false, then the statement is going to be true. Really, because I can't prove it. I need to catch you in the act, red-handed. You cleaned your room and mom didn't get you ice cream. That was a lie, right? That's a false statement. So with all of these things, this idea of just being able to look back, so with all the ones so far, I just looked back here and kind of filled out this truth table. We can go on with some of these things and say, well, now let's do something a little bit more complicated. What if I wanted to make the statement not P, then not R? In order to do that, I am first going to make, and I put that in red right there because I'm going to do a couple things and then come back to that one. I'm going to simply make this as part of my truth table. Like, not P really means the exact opposite. So in this sense, where P was true, not P is false. Where P was false, not P is true. Same thing with R. Instead of true, false, I now have false, true, true. Now don't get confused because I'm going to do this over here and then put the statement here, but I'm always going from hypothesis to conclusion when I am doing a statement in this order. Not P, then not R. And all I have to remember is that the only way for this to be false is to go from a true hypothesis to a false conclusion. Everything else is true. So right away, when I'm looking at this, going from false to false, that one's true because it started, both of these in fact, started with a false conclusion or a false hypothesis. So I don't care what the conclusion is, these are true. Here are the ones I have to investigate. This one went from a true hypothesis, false conclusion. This one went from true to true. So earlier I mentioned, like, are these two things the same? Like saying, if you clean your room, then you get ice cream, and if you don't clean your room, then you don't get ice cream. Are they the same? Looking back at these, I can say these are not exactly the same statement. Because look at the two truth tables. They don't match up in every sense, right? The true and the false going along and looking at these two conclusions. They don't match up. It's not a tautology. Tautology is when they're always true. These are not equivalent statements. So a couple other things that get a little bit more advanced when you're looking at this is, let's add another page here. You can take these statements. This is the normal conditional statement. I can turn it around, and it's referred to as the converse. The converse is if you clean your room, or excuse me, if you get ice cream, then you clean your room. I can do this one that I showed before, different letters, but this is referred to as the inverse of the original statement, where I literally took and put not statements in here. You don't clean your room, you don't get ice cream. And then probably the most complicated one, where you do both of those things, is referred to as the contrapositive. If you do not get ice cream, then you do not clean your room, right? So all of these things, just kind of taking those sentences and putting them in different orders. As you build a truth table, the other thing I'm going to say is probably if you ever see 3 letters on here, and you might have to do more, but you'll start to see this. A 3-letter truth table or a 2-letter truth table, I always start with true, true, false, false, and then I go true, false, and that gets all of it in there, right? If I were going to do a 3-letter truth table, and this is just a trick, you can always think through it just to make sure that you've got all of them. But if I see 3 letters that I have to use in my truth table, I typically go ahead and say, well, there's going to be 8 possibilities. Here's the 8 possibilities for P. Half of them are true, half of them are false. When I do Q, I usually end up doing kind of the same thing and saying, well, true, true, false, false, true, true, false, false. And this will make sense in a second. And then when I do R, I just end up doing alternating, true, false, true, false, true, false. And take a look at all the possibilities. Here's the only time that all 3 are true. Here's the only time that all 3 are false. Otherwise, I've got true, 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 false, true, right? All of the ways that you could have, almost all the ways you could have 2 trues. I have a couple down here. I've got true, false, false. It's just putting together all the different combinations for these 3 things so that I could make bigger statements later. You can also use, as I mentioned in some of the more complicated ones, you could have a statement like this: not P and Q, then not R. And it's really complicated to think through what that says. This says, if you do not clean your room and you get good grades, then you do not get ice cream. So in order to figure that out, instead of trying to think through all the scenarios for it, we would just start building this. I would build another section over here where I'd have not P. Then I would do a section that was this, not P and Q. And then I would have a section where I did the entire thing. I'd probably need a not R in there as well, but I do it in pieces so that eventually I get this statement, like just going through here. Well, not P is just the opposite of all of these. So here's false, 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 true, 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 true. Some people don't need to do this. They can think through that in their head. Not P and Q, they both have to be true. So this is false, true and false is false, 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 false. Here are the only true statements. I've got 2 trues. Everything else ends up being false. And then I would put the not R, and then I would evaluate the not P and Q if then statements. So we can do it all with those truth tables. That part usually takes people a little bit of practice to kind of get into. So really focus on understanding the symbols that are used, breaking down any sentence into the parts that could be true and false, writing them with letters, and being able to set up a truth table in order to evaluate whether or not these 2 things are true, or these 3 statements are true or false at the end. So hopefully that helps get you started.